Hello everyone, in this video I'll show you how to calculate the integral of the function cosine x power n in considering the lower limit of integration a and the upper limit of integration b. So how to calculate this integral? Let's calculate the derivative of sine x times cosine x power n minus 1. So if we calculate the derivative, we find that we have here cosine x times cosine power n minus 1. So we have here cosine x power n. Okay, then we have here minus sine x power 2. Then we have cosine times cosine x power n minus 2 times n minus 1. Okay, in fact here we apply the integration by parts. Okay, now cosine x power n it's equal to, so we have here the derivative of sine x times cosine x power n minus 1. Okay, then we have here n minus 1 times sine x power 2 cosine x power n minus 2. Okay, so we continue that we have here cosine x power n, it's equal to the derivative of sine x times cosine x power n minus 1. We have here plus n minus 1 times cosine x power n minus 2 minus n minus 1 times cosine x power n. Quite simply, because we have here sine x power 2 is equal to 1 minus cosine x power 2. Okay, so with some developments here, we can find that we have cosine x power n it's equal to 1 over n times the derivative of sine x times cosine x power n minus 1 plus n minus 1 over n times cosine x power n minus 2. Okay, we continue. If we apply the integration of for the two sides, so the integral from a to b for the function cosine x power n, it's equal to 1 over we have here the derivative, so quite simply 1 over n sine b cosine b minus sine a cosine a, then plus n minus 1 over n the integral from a to b cosine x power n minus 2. Okay, now for this equation, if we call this term in, because it depends on n here, we consider the same interval. Okay, so this term it's called in minus 2. Okay, wow, sorry, in parentheses we have a little error. We have here power n minus 1 and here we have power n minus 1. Okay, if we call this term in parentheses hn, so we have the following relation: in equal to 1 over n hn plus n minus 1 over n in minus 2. If you observe that we have here a recurrence relation, okay, how to apply this relation? if we have to, in fact, we have to start to calculate I0. I0 is equal to the integral a from a to b cosine x power 0. Okay, so here quite simply it's equal to b minus a, and we have to calculate I1, which is equal to the integral from a to b cosine x power 1. It's equal to sine b, yeah, sine b minus sine a. Okay, then we continue to calculate I2. For example, we consider this recurrence relation. Okay, so in I2, which is the integral from a to b cosine x power 2. If we apply this recurrence relation that we have here, 1 over 2 h2, we can calculate h2 quite simply, plus 2 minus 1 over 2, so we have here 1 over 2 I0, which is already calculated. Okay, now if we continue, I3 is equal to, we always apply our recurrence relation, so I3 is equal to 1 over 3 h3 plus n minus 1 over n, so 3 minus 1 over 3, so we have here 2 over 3 I1. Okay, I1 it's already calculated. Okay, and so on. We can calculate I4, it's equal to 1 over 4 h4 plus n minus 1 over n, so 4 minus 1 over 4, so we have here 3 over 4 I2, which is already calculated. Okay, and so on. Okay, now if we take a special case, if we have this interval from 0 to pi over 2, so we have here the upper limit of integration, which is equal to pi over 2, and the lower limit of integration, which is equal to 0, so hn it's equal to 0. In fact, you can verify that. Okay, so our recurrence relation can be written as follows: in it's equal to n minus 1 over n times in minus 2. Okay, we have this recurrence relation for this case. Okay, I hope that this video is useful for you, and wait me for other videos. Okay, goodbye.